and welcome back to Tall, also known as Teach as We Learn. Today we're going to be learning about transformations and are just going to get a general view of them, and then we're going to deep dive into reflections. So let's begin. So transformations is basically an operation that moves an original figure to a new figure. So basically something happens which changes the image. However, these transformations are congruent transformations, with congruent meaning that they have the same size and shape, but they're not necessarily equal to. So meaning that the size and the shape during these transformations change the same, but specifically their coordinates or where they're at just changes. And that can be seen through three ways. One, reflections. And reflections, you can think of it as a mirror. You know how our image reflects and we get to see our image on the mirror? Same thing with reflections. It's like a mirror. It reflects what it sees. So here we see a triangle, which almost looks like a YouTube play button. But basically, this reflects over this line and it's the same size and the same shape, but it's simply just reflected like a mirror. Then here we have translations. And in translations, it's a simple slide. These coordinates have been just moved point, right? This to here, and this point to this point. So it's just a simple move or a simple glide. And each point is shifted or slided in the same pattern, but we'll talk about that later. And then rotation is a simple turn around a specific point. That could be around the origin, or that could be another point, which is not the origin. But rotation is simple, a turn around a point. So now that we've sort of deeped a little into what a transformation is, let's talk about pre-image and image. So pre-image is our original figure, right? Original figure without the transformation. And then our image is our new figure, right? Which has been modified with the transformation. But how do we identify that which one is a pre-image or which one's an image? So that can be seen whenever, especially when we're talking about graphs. That can be seen with a line and the point without a line. So a point without a line is typically the original figure, or the pre-image. And this letter or point with a little dash, that symbolizes that this is the modified or new image. So that's how you can tell which one's a pre-image and which one's an image. So this triangle over here, since none of the points have a dash, would be a pre-image, and these triangle ABC would be the image since it has the stashes. So now let's deep dive a little into reflections. So again, reflection is basically a flip, right? You're reflecting. It's like a mirror. You're reflecting something over. However, there are multiple types of reflections, right? There is not necessarily one way to reflect a point. So in this case, we can see that our point got reflected from the y-axis, right? It was here, then it moved across the y-axis to over here. And as we can see, that is one way we can do so through a formula. But let's suppose we have a point called point A, and this point is 2, 3. If I would want to reflect it over the y-axis, then I'd use minus x, y. So it would have become -2, which would be -2, 3, right? Because we make our x negative, but our y is still the same. So -2, 3 would be in this quadrant right here, and would write -2, 3. And we can see that, yes, indeed, it has reflected. And that too over the y-axis. But we can also reflect it over the x-axis. So if my point A is 2, 3. Then I can use this, instead of using this formula, I can use this formula. So it would be x minus y. So that would mean that this time, instead of changing my x's stay the same, but instead of 3, it would become negative 3. So 2, negative 3 would be in this quadrant, and this would be my point. So now this has reflected over the x-axis. However, we can also just, instead of reflecting it over the x-axis, y-axis, we can reflect it over y equals x and y equals minus x. And what I mean by that is y equals x is something we did learn in our Algebra 1 course, right? It's basically a line that starts at the origin and has a slope of 1. So if I draw this line, which is not drawn scale, right? Just something accurate, this line, then I would want to reflect my line over here. So right now, this is 2, 3. I would just flip the numbers, so it would become 3, 2. So maybe here, here, and this would be reflected. Be a little closer. But we can see that instead of reflecting over the x and y axis, it's reflected over this line. And then it's the same thing for y equals negative x, but instead of having a positive slope, it has a negative slope. So if I reflect it over here, so 2, 3 would be flipped, so it would be 3, 2, but then we'd put our negative, so this would become negative 3 over 2, and negative 3, negative 2 would be somewhere like here-ish. And we can see how it's reflected. So ignore the green line, but look at the orange line. This original point, and now this is our new point. So this is how reflections work. It's basically a mirror, but it can be a mirror across many lines. It could be the x-axis, y-axis, y equals x, or y equals negative x. So that is it for today's video, and I hope you enjoyed. Bye, y'all.